Hello students, so we continue with the chapter trigonometry and today we are going to solve few sums and these sums will use the trigonometric formulas which we had studied in the last video and these are the three sums and the most common thing in the sum is to prove the left hand side is equal to right hand side. So if you can see that there is a left hand side given, this is the left hand side, this is the right hand side, and left hand side has to be proved to the right hand side. Now the best thing here is since the right hand side is given, right, we will get a hint how to proceed. Okay. So in question number one, square root of 1 minus cos A upon square root of 1 plus cos A, we have to prove that this is equal to sin A upon 1 plus cos A. Now the first hint which I am getting here is that there is no square root on the right hand side. So the first step should be to remove the square root. Okay. So what is in the denominator? I'll write first. This is 1 minus cos A. Okay. And in the denominator, it is square root of 1 plus cos A. Now, if I have to remove the square root from the denominator, right? If you remember, if I multiply with the same number, my square root will go. And this is class 9th topic, the chapter rationalization, where we had studied that if there is a irrational number square root 2, and if I have to convert this into a rational number, I multiply it with the same number. And what I get is 2, right? So square root of 2 into square root of 2 is 2. I hope you know this. Square root of this becomes 4. 2 into 2 and the square root of 4 is 2. All right, so this is what we are doing here. To remove the square root, we are multiplying it with the same number. And if I have multiplied in the denominator with this, I will have to multiply in the numerator with the same number. I hope this was easy to understand. Okay. And now what this becomes in the next step is the denominator becomes 1 plus cos A, right? Root 2 into root 2 is 2. So root 1 plus cos A into root 1 plus cos A is 1 plus cos A. The square root is gone. And now if we see the right hand side, we actually have to get 1 plus cos A. Half of the question is done. Now let's come to the numerator part. So numerator, inside the square root, there are two different numbers. Please be careful. So we cannot just remove the square root. So square root will remain and we will multiply the two numbers, right? The two numbers inside will be multiplied. So 1 minus cos A into 1 plus cos A is 1 minus cos square A. Okay. I hope you can multiply. This is A minus B. This is A plus B. If you recall from the chapter identities, it is A square minus B square. And this is what I have written, A square minus B square. Okay. And now the trigonometric formula comes in. What is the trigonometric formula I'm going to use? That sine square theta plus cos square theta is equal to 1. I hope you remember from my last video, a very important formula, sine square theta plus cos square theta is equal to 1. And here I am going to replace 1 minus cos square theta. If I take this here, it becomes 1 minus cos square theta. And what is this equal to? Sine square theta. And this remains 1 plus cos A. And the last step is, okay, so this is not theta, but this is A. What is square root of sine square A? Is sine A upon 1 plus cos A, and this is equal to the right hand side. All right, a quick summary. Focus on the right hand side. We will start getting the hint. There is no square root. I will have to remove the square root. Okay, and basic maths tell us that if in the denominator I have to remove square root, I will have to multiply with the same number. And since I'm multiplying with something, I will have to multiply in the numerator also with the same number, just to keep the fraction equal. Basic maths. And then we proceed. The denominator square root is gone, because if I multiply with the same number, I get the number itself. So I got a 1 plus cos A. All right. And in the numerator, I got multiplication of 2, a plus b, a minus b. So 1 minus cos square a square minus b square. This becomes sine square a, and we get sine a of 1 plus cos a. All right, let's do the second sum. And here again, we will see what is given on the left-hand side and what is to be done on the right-hand side. So the left-hand side, there is a fraction given, 1 upon sine a plus cos a plus 1 upon sine a minus cos a. And we have to prove that this is equal to 2 sine a upon 1 minus 2 cos square a. All right. So if there is a fraction given, okay, this is like given 1 upon 3 plus 1 upon 4, right? This is like a fraction. So what do we do in a fraction? The first thing what we do is we take the LCM of the two numbers in the denominator. Okay, so what is the LCM of 3 and 4? Is 3 into 4, right? 12 is the LCM, 3 into 4. So similarly, when there is nothing common between the two, I simply write in the denominator sine A plus cos A, and in another bracket sine A minus cos A. Okay. So this is the LCM in the denominator. And if you know how to calculate the fraction, just cross multiply 4 plus 3, right, in the numerator. So what am I going to write here? If you know the fraction, sine A minus cos A. All right, sine A minus cos A, this one will go here, and plus this will go here, which is sine A plus cos A. This is basic maths. Okay. And now if you see in the numerator, cos A gone, minus plus, I'm left with 2 sine A in the numerator. And what I am left in the denominator, again, you see the basic identity, a plus b into a minus b in the denominator. And what is a plus b into a minus b? A square minus b square. So this is what sine square a minus cos square a. Okay, sine square a minus cos square a. But is this what we have to prove in the right? No. 2 sine a is perfect, but in the denominator, we have to have only cos and no sine. So we know the relationship between sine and cos. So let me convert this further. 2 sine a upon, what can I write for sine square a? I can write 1 minus cos square a. And there is another minus cos square a. Okay. And this is what is the right hand side, 2 sine a upon 1 minus 2 cos square a. Right. So now this is the right hand side and hence proved. So I hope you could understand what I have done. The first thing is, the moment there is a fraction given, please take the LCM of the denominator numbers, this one and this number. If there nothing is common, right? If there is nothing like 3 and 4 common, I take the multiplication 3 into 4. Okay. And when I take the LCM here, I will write the cross multiplication. I'll do the cross multiplication and I get sine A minus cos A plus sine A plus cos A, cos A gone, 2 sine A in the numerator, right? 2 sine A in the numerator, and in the denominator, this is A plus B into A minus B, which is A square minus B square. All right, and we do this sine square A minus cos square A, again converting sine into cos. Why am I converting sine into cos? Because my right hand side is giving me the hint that I don't want sine, I only want cos. And so here is the right hand side. All right, let's do one more variety, question number 3. And again, the rule remains the same that, hang on. Yeah. So yeah, question number 3 says that on the left hand side is given cos theta cot theta upon 1 plus sine theta. This is the left hand side. And what we have to prove is on the right that this is equal to the right hand side cosec theta minus 1. Now, if you remember that cosec is the inverse of sine. Do you remember that I told you in the last video, write PBP Pune, Bombay, Pune upon HHB, right? Happy birthday. And what was the first one? First one was the sine. Okay, sine is perpendicular upon hypotenuse. And what was here in the denominator? Cosec. Cosec means hypotenuse upon base, hypotenuse upon perpendicular. So sine and cosec are inverse. So what I'm trying to tell here is that cosec is nothing but the inverse of sine. So somewhere in the right, I need something sine, right? And in the left-hand side, I am given cos, I am given cot, and yes, there is one sine in the denominator. So what is the first step? Convert cos and cot into sine and cos. All right, so let me first convert the cot theta. If you remember, cot theta is nothing but cos theta upon sine theta. Okay. And the denominator I am going to keep as it is, right, in terms of sine, 1 plus sine theta. This is the first step, from the left-hand side we can do on the basis of the hint given in the right-hand side. Okay, so we are all bringing to sine because cosec is the inverse of sine. Okay, now my entire thing is in cos and sine. All right, so here it becomes cos square theta upon sine theta and in the bracket 1 plus sine theta, right? Very simple to do. Cos square theta, this sine theta is in the denominator, so sine theta into 1 plus sine theta. Now cos square theta, again we have to move to sine, right? Because we have cosec on the right. So what is cos square theta? Now you remember that there is a formula sine square theta plus cos square theta is equal to 1. I can easily change cos square theta to 1 minus sine square theta. And in the denominator, it remains same, sine theta in the bracket 1 plus sine theta. All right. And the last step, if you know this, we have done many number of times here now. 1 minus sine square theta is nothing but a square minus b square. So the reverse of the identity, this can be written as a plus b 1 plus sine theta into 1 minus sine theta. Now this is a pure identity from class 9. A square minus b square can be written as a plus b into a minus b. And here we have in the denominator sine theta in the bracket 1 plus sine theta. Okay. Now very clearly you can see that 1 plus sine theta, 1 plus sine theta gone. And what we are left with is 1 minus sine theta upon sine theta, which I can write as 1 minus sine theta upon sine theta, right? Right? 1 minus sine theta is left in the numerator and sine theta is left in the denominator. Okay, so now again, basic maths. 1 upon sine theta, 1 upon sine theta. Okay, take this part. 1 upon sine theta is nothing but the inverse, which is cosec theta. Remember, Pune, Bombay, Pune upon HHB. So the first one was sine. What is the reverse? Cosec. So up opposite of 1 upon sine theta is cosec theta, and minus sine theta upon sine theta, which is 1. So what we got on the right hand side is cosec theta minus 1. And this is the right hand side what we had to prove. I'm sure with these three sums, you got the method to solve. See, every question needs a method, needs a automatic thinking process. So if you can follow that, then proving or proving to the right hand side becomes easy. I hope, just to summarize, in the first one, there was no square root in the right hand side. So we multiplied square root in the denominator, in the numerator, and we saw answer coming. In the second one, two fractions were given. What do you do when the two fractions are given? You simply take the LCM, and this is what we do in the normal mathematics. And we took the LCM, we solved it, and we got the right hand side. So first thing first, okay. And the last one said we have to get cosec. Cosec is the opposite of sine, inverse of sine. Somewhere we have to change this cot theta. Cot theta is cos theta upon sine theta. And with this, we kept on solving basic identities you cannot forget. And we got the right hand side. Hope you like this. I hope you will practice more. And this will help you in solving every sum in the exercise.